In graph, there are two types of graph. The first is directed graph, and we write digraph. So basically, and then also undirected graph. And similarly, we don't spell the whole thing. We just said it's undigraph. For directed graph, 1, 2 is not 2, 1 because this means 1 point to 2. This means 2 point to 1. But for undirected graph, it means 1 connected to 2 and 2 connected to 1. We also have something called simple graph, multi-graph, and pseudo-graph. So what is pseudo-graph? You can have self-loop and you can have multi-edge. So what is multi-edge? For example, this means multi-edge. So you have 5, 3. So we have 5, 3A and 5, 3B. And if we allow this is called multi-graph. And if we allow self-loop, okay, that means connected to itself. If we allow both, this is called a pseudo-graph. Mostly, we do not talk about pseudo-graph, okay? And then if we do not allow self-loop, but we allow multi-edge, this is called multi-graph. Multi means multiple edge, okay? And we also do not talk about multi-graph. We most of the time talk about simple graph. Simple graph means we do not allow self-loop and we do not allow multi-graph. So for example, in this picture, 4 can connect to 3 in 2 ways, okay? And 5 can connect to 3 in 2 ways, but we will only count 1 way. So this is the same as we do not count 5, 3 in a set 2 times. So remember, in a set, if you have 2 elements that are the same, you count them as a single element. So in graph, we will call it simple graph. That means we don't count repeated element. So this is another classification. So the first classification is whether you have arrow or no arrow. The second classification is you have loop, multi-edge, or no loop, no multi-edge. Okay. So how do you connect from multi-graph to simple graph? 3,5A, 3,5B is the same as what? You add a node called 3A, 3B. You add a node called 3A, 3B, and then what? You create a connection between 3A5 and 3B5. And then what's next? We can always change the name, right? So I can change this 3 to A, right? Then I have an A. And then I can also change this 3B to B, right? Then I have B, okay? Then A. Then this is the same as I have a new graph, but now I have new labels, A and B and 5, okay? So for this graph, 3, 4, and 4, 3, again, we split 3 to 3A, 3B, and then we have this, okay? Here's a mistake, this should be 4, okay? And then for this one, so this is basically the two cases work together. So now 3, I've split it to 3A, 3B, and now I rename 3B as 6. So remember, this is 3B, this is 3A, okay? And then I have this graph. So now you see, this graph I have multi-edge. 3, 4 have 2 lines, 3, 5 have 2 lines. But now in this case, 3, 4 and 3, 5 both only have 1 line. And I created a 6 that has 6, 4 and 6, 5, okay? So this one have no self-loop, no multi-edge. This become a simple graph, okay? So here is an example of how to draw a graph from incidence matrix. So I have this without a figure. So how do we draw it? So this means 1 go to 1 has nothing. This means 1 go to 2 has a line. This means 1 go to 3 has nothing. So you just draw 1, 2, 3. Okay, 1 go to 2, right? So you draw this. And then what does it mean? This means 2 go to 1. Okay, so 2 go to 1. And then 2 go to 2 is nothing. Okay, and then 2 go to 3. So 2 go to 3. And then 3 go to 1. Okay, 3 go to 1. And then nothing. So that's it. This is the graph. Okay. And if I rename this 1, 2, 3 as x, y, z, then I will get this, okay? And for this particular naming, x, y, z, I can also get the edge set. That means what are the ij in this graph? So for example, x connected to y, so I have xy, y connected to x, so I have yx, y connected to z, so I have yz, z connected to x, I have zx. And there are 4 lines, okay? 4 lines. And there are 4 non-zeros, okay? In set theory, the extreme case is empty set and universal set. In graph, the extreme case is null graph, empty graph. So basically, it's with no edges. So E is empty, okay? And this is null graph. It's not interesting. And the opposite case is complete graph, okay? We call it complete, okay? That means all ij are connected, okay? All the ij are connected. For example, for this graph, 1 is connected to other people, 2 is also connected to all the other people, 3 is connected to all the other people, 4 is also connected to all the other people. So in this case, I have 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. This is an undiagrammed graph, no arrow, okay? And then how many nooks? 1, 2, 3, 4, 1, 2, 3, 4. How many of them? 4, okay? How many edges? So this is same as what? How many nooks? I have 4 nooks. How many nooks I need to form a line? I need 2 nooks to form a line. I have 4 nooks. Okay? What is this? I have V equal to 4. Okay? So this is V. What is this? This is V minus 1. What's this? This is divided by 2. So actually you can also calculate the number of edges in a complete graph by V times V minus 1 divided by 2. Or you just simply V choose 2. Okay? So this is again combinatorics. And then what's the adjacency and the incident matrix? So here we do not care about arrow, so A and M are the same thing, and we have this. So what does this one mean? This one means 2 is connected to 3. What does this one mean? This means 3 is connected to 4. Okay? And because every node is connected to other body, so all the degree are the same. And what is this number? This number is V minus 1. So that means for a complete graph, we will have the following property. It will be v number of nodes. It will be v times v minus 1 divided by 2, or v choose 2 number of edges, and the degree will be what? Will be exactly v minus 1, okay? And this is a diagonal matrix. We can even say that this is di-v, okay? And these two graphs are the same thing. So this is a graph. I draw it like this with crossing. This is a graph with the same drawing without crossing. Basically, it's just I move this guy inward to here, okay? So as a practice, you should practice write down all the vertices, vertex set, number of vertices, edge, S set, number of edges, incident matrix, adjacency matrix, and degree matrix for these 31 examples.